Hi, my name is Ashwant and welcome to this lesson on an introduction to reactive programming. In this lesson, we'll be covering the basic concepts of reactive programming such as observables, observers, subscriptions, etc. Marble diagrams are the standard way in which operators are explained in the documentation, so we'll also look at how to interpret marble diagrams. We'll start writing some reactive code using RxJS, and we look at different ways of creating and subscribing to observables and how to go about working with operators. We'll also look at a comparison between a reactive and a proactive approach and why you should prefer the reactive approach. To work with the reactive paradigm, we need to use an API called ReactiveX, which is short for reactive extensions. ReactiveX is an API for asynchronous programming with observable streams. If these terms don't make sense to you yet, don't worry, I'll be explaining these terms in due time. ReactiveX is an ubiquitous API and is actually available for different languages such as Java, Scala, C#, C++, Clojure, JavaScript, Python, and several others. In this lesson, I'll be using the JavaScript implementation of this API called RxJS. If you've ever worked with Angular, there's a good chance you've already seen RxJS in action, since a lot of the Angular APIs expose this functionality as observables. When I started working with reactive programming, it took me a while to be able to think about my system in a reactive manner, predominantly because I found digesting the plethora of concepts that come with the framework a little bit challenging right off the bat. While it may be tempting to just jump in and start trying to figure out how to use RxJS operators from the documentation, in my experience, this can lead you down a path where you don't have a clear understanding of what's actually going on and why something is not working the way you expect it to work. I think it's certainly worth your time to understand the basics of what reactive programming is and being able to think from a reactive perspective on how events drive your systems using first principles. So, what is RxJS? RxJS is a library that lets you write code using the reactive programming paradigm. A programming paradigm, in simple terms, is just a way of thinking about your code. It's a mental model of how you go about writing code in that paradigm. You've probably used some popular paradigms such as imperative, object-oriented, and functional programming paradigms. Like functional, reactive is a declarative paradigm and is in some ways an extension of the concepts of functional paradigm. The reactive paradigm is primarily concerned with asynchronous data streams called observables and the propagation of change in your system. A reactive application will react to events. For example, when a user clicks a button on the web page, this is an event, and your application can react to this event. Observables are an alternative to promises, and in many ways they can be similar but also very different. I'm not planning on going into detail about the similarities and differences between the two in this lesson. There's actually a very good talk by Ben Lesh on this topic, which I would highly recommend watching after you have a basic understanding of RxJS. I'll provide a link to this talk in the description below. To understand the notion of observables, observers, and subscriptions, I will use an analogy from the real world so that it's easier to understand these concepts. Keep in mind that this is merely an analogy, so there will be points where the two models in the analogy will deviate from each other. You can think of an observable as a YouTube channel. In this case, I have a screenshot from the homepage of the Netflix UI engineering channel. A channel can have several events that occur. For example, it can have an upload event when a video is uploaded to the channel. You can subscribe to the channel and you will get notifications whenever the channel has an event. You can react to this event, say that of a video upload event, by clicking on the new video to watch it. You can also unsubscribe from this channel to stop receiving notifications about events. An observable works pretty much the same way. An observable has events. You can subscribe or unsubscribe to an observable. You get notifications on events, and a subscriber can react to the events. A subscriber is called an observer in this paradigm. From our previous analogy, you as the user are the observer. You can observe the channel for events. When you, the observer, subscribes to a channel, you have an active subscription. So, in the reactive paradigm, an observer can subscribe to an observable to create a subscription. You can distill useful information into an event timeline. Here we have a timeline where the arrow represents the flow of time. We are typically interested in the timeline only after you subscribe and have a running subscription. So our timeline starts at the subscribe event. Once you subscribe, after a period of time, the observable can have an event, which is represented as the yellow dot on this timeline. And whenever there's an event on the observable, the observer is notified of this event. And you can also unsubscribe from this observable at any point of time. I do want to mention here that observables are lazy by nature. So they do not emit any events if there is no observer who's subscribed to it. This is a bit of a deviation from our analogy, because you can have a YouTube channel with 0 subscribers and still have events on the channel. This event timeline gives a very nice segue into understanding how to interpret marble diagrams. This is an example of a marble diagram. You will usually see different variations of this in different sites or documentation, but the way to interpret these diagrams can be extended across all these sites. The arrow on the top is our observable, the source for all our events. And as time goes on, you can have different events that can occur spaced out or in rapid succession. The value of the event emitted can be transformed before it reaches the observer using operators. You can have one or many operators that transform this data. You can even have operators that dispatch side effects. For example, the tap operator, which is super useful for debugging purposes. An important thing to note here is that any event that occurs on the observable after the observer unsubscribes from the observable is not notified to the observer. You can create an observable by importing in the observable class from RxJS. You use the new keyword to create an instance of the observable class, and you need to pass in a callback as an argument to the constructor. Inside this callback, we ask the observable to emit events using the next method. The observable will first emit the value 1. Because we have a set timeout, the emission of the next value is delayed. The value 2 is emitted 1000 milliseconds after the value 1 is emitted. After 2 is emitted, we then call the complete method to terminate or clean up the observable. And like I mentioned before, because observables are lazy by nature, the observable created here is not emitting any value just yet. It needs a subscriber to subscribe to it before it can emit the values 1 and 2. In terms of the event timeline, this is how our observable will look. Once we have an observer which subscribes to the observable, the value 1 is emitted at approximately 0 milliseconds from the start of a subscription. And 1000 milliseconds later, our next value, 2, is emitted, and then immediately after that, the observable completes. While we just saw how to create an observable using the observable class from RxJS, you would usually not create observables in this manner. RxJS provides several utility methods that can assist you with the creation of an observable. Here we have the off method, which can take a series of values as parameters, and your observable will then emit these values when subscribed. You can create the exact same observable using the from method as well. The only difference here is that you would pass the values to be emitted as an array. We can subscribe to an observable using the subscribe method. You can pass in an object as a parameter with the properties next, error, and complete defined. This object with these properties is your observer. The subscribe method returns a subscription object. The subscription object has the unsubscribe method. You can call the unsubscribe method, no surprises here, to unsubscribe from the observable. Every time the observable emits a value, this value is passed into the next callback. If there is an error thrown in the observable, this error is passed into the error callback. When the observable terminates, the complete callback is invoked. RxJS provides a shorthand way to call subscribe and pass in the next error and complete callbacks directly instead of defining them as properties in an object. This is usually the preferred way to subscribe to an observable. Operators are the bread and butter of the reactive paradigm. We have already seen some creation operators like of and from, which help with the creation of observables. From event is another such creation operator which helps with creating observables from events. For example, the click event. Here, we are creating an observable that will emit every time a user clicks on the document or the web page. However, we don't directly call the subscribe method on the observable. Instead, we call the pipe method and then chain the subscribe method. On each click, the click event is passed through the pipe and then to the observer. The pipe method is used to transform each event using pipeable operators and passing on this transformed event data to the observer or subscriber. Here we see an example of a pipeable operator in use, the scan operator. The scan operator works similar to array-reduce method in JavaScript. It takes a seed value of 0, which is set to the variable named count, and each time the observable emits a value, it will increment this count value and pass the count value to the observer. The marble diagram for such an operation would look like this. The observable emits events with the click event value, which is the pointer event object, and the scan operator overrides this event value with the local variable count after it has been incremented and passes this data to the observer. In the first event, the observer receives the value 1, and then 2, 3, and so on. Our observer merely logs the count value on each event. One question you might be asking yourself at this point is that why should I write reactive code? And that's a very good question. There are some obvious benefits listed in the ReactiveX website about how observables make your life so much easier, especially when dealing with asynchronous operations. But there is also a more subtle but important benefit when working with reactive. I'll try to explain this benefit using this example. Imagine you have two modules, Module 1 and Module 2. In Module 1, you have your handle click method attached as the event listener to the document. On click, the handle click method invokes the increment method from Module 2. Module 2 has the counter state and an increment method which updates this state. So in this example, we have Module 1 driving the state and behavior of Module 2 using the increment method. Therefore, we can say that Module 2 is passive and allows other modules to change its state, which means Module 1 is now responsible for changing Module 2's state correctly. In Reactive, we invert this relationship. Here we have Module 1, which creates a click observable, and we have Module 2, which subscribes to this observable from Module 1. So we have Module 2 listening to Module 1 for any events within Module 1. Thus, we can say Module 2 is reactive and drives its own behavior and state when a click event is emitted. To re-emphasize, Module 2 is responsible for acting upon its own state. Therefore, the benefit of reactive here is that it drives the implementation of self-responsible modules which focus on their own functionality rather than changing external state. This builds on the principle of separation of concerns, which is widely agreed upon as an important principle when writing software. Since this is purely an introduction to RxJS, the idea with this lesson was to focus on building the basics so that you can start working with the reactive paradigm on your own. Going forward, I would recommend that you are aware of the following points. The biggest challenge with reactive programming is this paradigm shift of being able to follow the reactive approach over the proactive approach by default. Another key challenge is that there is a multitude of operators available for different situations, and being able to identify which operator is needed for which situation takes time and experience. When working with observables, it's also important that you're aware of the notion of hot and cold observables and understand when you have a need for a hot observable. RxJS also has subjects which are a special type of observable which lets you multicast values to many observers, and you will probably end up needing to use subjects very frequently. You also have more specialized versions of subjects, such as behavior subject, replay subject, and async subject, which can be useful based on your need. Another thing you should be aware of is that you can test your asynchronous RxJS code using marble syntax, resulting in tests that run synchronously and deterministically. I plan to cover all of these concepts in future lessons. In the meanwhile, I hope you found this introduction an easy way to get familiar with the reactive paradigm. In case you're looking for a text version of this lesson to go back to, you can find one on my website at this link here. Feel free to reach out on LinkedIn or email if you have any queries. Thanks for watching.